I've now completed the transformer and I've put the E and I cores back in. When I first did it, the cores rattled quite badly, and I found that there was a fairly large gap between the I's and the E's, caused by the bobbin cheeks spreading out slightly when I wound it. I should have used a large frame to keep the cheeks nice and straight. Anyway, as it turns out, I was able to, using clamps, squeeze them together, and I also used lacquer between laminations that were loose. I'll turn it on and I'll show you the 6.3 volt winding. There it is there. It's actually reading 6.6. It's got a 12 volt globe on it as a bit of a load. It's not the full 10 amps. And I'll show you the high voltage reading in a moment. So I've now connected the high voltage probe to the multimeter. This is a 1000 to 1 probe, good to 40 kV. I wouldn't use anything less. I wouldn't go anywhere near that without anything less. And I've also made myself a little reminder that it's highly, highly dangerous. If you don't know what you're doing, don't go anywhere near this type of work. And we're reading 864 volts. So that's working okay. I also have a tap there for 110 volts for the fan. The linear uses a 110 volt fan. There's also a frame to go around the whole thing, and these particular bolts that go through have an insulator, and the idea of that is to I guess reduce hysteresis loss due to induced currents going along the bolt and touching the laminations. So I've got to put these back in and I've got to fit the frame. I've had to make some little cutouts to clear the wires, and I've used some glue to keep the wires firm on the cheeks. So the next step is now to take the transformer and put it in the linear and see how it goes there. The high voltage should be okay for a pair of 572Bs. There's actually a voltage doubler in the linear amplifier, so the 860 volts less some will be around the 2,500 volts, which is okay for a pair of 572Bs. We've finished testing the transformer on the bench, so I'm now getting ready to put the transformer into the linear case. We've drawn up a little circuit for ourselves with some information. I've put a new tag strip inside the linear, and we've got some information where all the wires come out of the transformer for future reference, and the number of turns and the resistance of each of the turns. I've also made a tap down here which will provide around 30 volts AC, which I'm hoping to use for a soft start relay at the input. So before I fit the transformer into the case, I need to do a few things to the linear itself. First of all, it came with a rather heavy duty power lead, which is more of an industrial frying pan type. It went through a rubber grommet which was in poor condition, and it was zip tied in, which was not satisfactory, so I fitted an IEC connector. Having done that, having modified this equipment, there's a thing you need to take note of. I have a testing and tagging license. This has now been modified, so it requires some testing to be done on it. And just briefly, some of the tests are that there has to be less than 1 ohm between the earth pin and the case, and it needs to be able to take 20 amps of current for at least 1 second. Secondly, the leakage has to be less than 5 milliamps to any of the live parts of the case. And thirdly, there has to be no less than 1 meg of insulation resistance, and that has to be tested at 500 volts between the incoming supply and the case. So a few other things, like you need to inspect the case to make sure that that it's safe, and so on. This is for only home use. However, I like to do those tests just for my own safety. We've rewired the back. I've put a new tag strip on there, and I've also put some heat shrink over critical 240 volt components, such as the fuse. It's a brand new fuse holder, and some heat shrink over the various connections that are high voltage. That will get a cover over it as well, with a label on it telling me what's in there. We've It has a rather ordinary on-off switch, and the leads going to the power switch were exposed. So I've put some heat shrink over the connections as far as the heat shrink will go down. There's a sort of a rivet there that won't let it go any further. I'll just show that. And we've removed all of the bleed resistors or equalizing resistors across the capacitors, and the reason for that is we wanted to test each capacitor individually for ESR and for leakage and value. So I've removed the resistors temporarily. They all seem to be okay. The ESR's around 0.5 of an ohm, which is okay for a 100 mic 450 volt capacitor. The actual leakage will have to be done with a voltage on it, and it might also help to reform the electrolyte if it needs it. It's usually done with a higher voltage and with a resistor in series to each capacitor, and you just measure the volts across the resistor, and that'll tell you whether there's what sort of leakage you're getting. You will have a little bit, but you don't want too much. The rectifier stack is all been cleaned. It was all covered in dust, and I've replaced some resistors that go to the metering, which were pretty dodgy. They're little half-watt ones. They weren't in very good condition. This is an original resistor, 3 meg. I think it's 3 meg or 1 meg, and then I had added some more 3 watt resistors. So the other last thing is that the sensitivity pot used for the SWR down there is scratchy. Doesn't sound too good, so I'm going to replace that. Well, I've now finished the rebuilding of the transformer and fitted it into the case of the linear. I'm now about to test it. Just a few things. I've got a high voltage probe here for testing the EHT. When you're mucking around with voltages that kill, it's a good idea to have something like that on your hands. A bit awkward, but these will stand 5,000 volts. And when you're testing the electrolytic capacitors, you might want to wear something like that. They have a habit, if a thing's not working properly, of exploding a bit like a cartridge, shotgun cartridge. The last thing you want is find bits of capacitor in your eyes. So I'll turn it on, and I have the meter here. That's on the filament voltage, and it's showing 6.38 or thereabouts. And over here I have the meter with the 1000-to-1 probe on the EHT output. I'll just measure that, and we're looking at 746 volts. Now, what I've done in order to test the electrolytics, instead of putting the full supply on there, I've actually put a resistor in series going between the high voltage and the rectifier bank, and that limits the voltage on the capacitors to around about 50 volts each. I just want to see if they're going to at least survive that. No short circuit, put it this way. So I'll give you a view of the electrolytic area, and that resistor you see is actually 4 150k 3 watt resistors between the 750 volts and the rectifier stack. Before I go any closer to that, something like that, just even for the demonstration, I have these gloves on. So there's 750 volts there, goes to the voltage doubler, and that feeds 6 electrolytics, 100 mic, 400 volt, 450 volt each, and we've measured the voltage across each as around 50 volts. So you can have a look at that. So we go to DC on the meter, and we look at the first one. It's 51 volts, and they're all pretty roughly 50 volts, which means the all the equalizing resistors are working. After this demonstration, I can then reduce the resistance and start putting more and more volts on the capacitors so that they will reform, hopefully. So that's it for now. I will continue the tests with the new transformer and see if I can then test for the RF. I believe the tubes aren't too bad, but you never know until you put RF through them.